In this lecture, we are dealing with very much realistic type of situation where there are multiple masses on multiple plane. Previously, we started with the single mass on a single plane, then multiple masses on a single plane. Now, a very realistic situation is the masses will be distributed on number of planes. So this lecture is all about multiple masses on multiple planes and how to balance these unbalanced masses. So there are multiple rotating planes, and on each plane there is a unbalanced mass. Maybe these rotating planes represent gear 1, gear 2, gear 3, and all these gears are mounted on a single shaft. Maybe these rotating masses, they are representing some like pulleys, pulley 1, pulley 2, pulley 3, or whatever you can think about. So these multiple rotors can represent any of the system. However, on each plane there is a single unbalanced mass. For example, if there are three gears on a single shaft, gear 1, gear 2, gear 3, and each of the gear, one of the teeth is broken. So teeth is broken, there is some unbalanced mass, teeth is broken, some unbalanced mass, teeth is broken, some unbalanced mass. So you can think about different scenarios. The schematic diagram of this system can be represented by top figure and the bottom figure. Both has merits and demerits. For example, the top one, we can see the mass m1 at some radial distance r1, mass m2 at some radial distance from the axis of rotation, mass m3 at some radial distance from the axis of rotation. So this one line, the blue line, represents axis of rotation. Here is the axis of rotation. Also, the distance between the axial distance between mass m1 and m2 can be obtained here. Axial distance between mass m2 and m3, and similarly axial distance between mass m1 and m3 can be seen. The only drawback at the top figure is we can't see the angular position of mass. So in the bottom we can see the angular position. For example, if you assume the mass m1 is on horizontal axis and the force produced by this unbalanced mass f1 can be represented by fm1. The fm2 is at some angular position with respect to horizontal, and it will be angle theta 1. And the force produced by this unbalanced mass m2 is fm2. The third and the last is the mass m3 on plane 3, and it is at some angular position with respect to center of axis or axis of rotation. So angle theta 2 is the angular position of m3 with respect to horizontal, and the force produced by this m3 is fm3.